So this is a brief introduction to servo and proportional valves, what they are, how they work and where they're used. They're both identified by this symbol. The difference between a directional valve symbol, the internals are the same here, are these two lines which indicate the valve is proportional, so rather than opening from one side to the other, it opens gradually and giving different flow depending on the position it's at, and that's control. We may see as well the arrow across the solenoid, which shows it's a proportional solenoid. It's moving gradually rather than just from one side to the other. So these are two common types of valves. This is a mobile slice valve, and this is a sandwich plate industrial valve. So the key thing that makes it proportional are these notches. We've got round notches here, and we've got angles, tapers on the spool here. So that means it's not one flat land which is either open or closed. We can gradually open and we can restrict the flow as it opens. In the mobile valve, you've either got a lever on the end. With mobile valves, it will be typically for excavator arms, dozer arms, so you've got gradual control. The operator wants a little bit of speed control and smoother opening, very often controlled by pressure reducing valves that apply a pressure against the spring on the spool. In industrial, it's generally a little bit different, that you want to control a machine and cycles, hundreds and thousands of cycles, that need to be exactly the same, so you would want to be able to control the speed and the stopping and the starting very accurately and very smoothly. This is quite a complicated valve. Again, we've got our pilot up here controlling the pressure on either end of the spool and the position of the spool, and then we'll have a position feedback. So there's a lot of electronics here making sure we very accurately control the position of that spool. So we're going for accuracy in industrial very often. So let's just have a quick look at how they appear, what they look like. This would be a mobile applications with hand levers, so the operator just moves those and has got good control of the position and speed of his equipment. This is a traditional servo valve. Performance, really, servo and proportional valves, the top end proportional now are as good, if not better, so the term servo and proportional does get a little bit confused. Traditionally this has a flapper inside controlling the spool. That was the traditional servo. This is purely electronic, so rather than a flapper controlling the feedback, we've got a lot of electronics. And over here you can see proportional valves can be very low cost these days. Pretty much all valves can have a proportional option, flow and pressure, reducing and relief, so they may not look a lot different to a normal directional valve or pressure control valve. So let's go now and have a little experiment. This is directional. We can see there's no notches in the lands, and we've exaggerated what happens by the roughness and the vibration. Basically, the reason you'd switch from, or one of the reasons you'd switch from directional to proportional, is because as you change direction, you get a lot of shock loading, you get a lot of noise that you don't really want. So if we were to switch in a proportional spool with our little notches, and we've got control of speed opening and closing, we can now see a nice ramp. So it's opening smoothly, set speed. In this case we're not controlling the speed, just the opening. The acceleration and deceleration is the opening speeds, which give smoothness. As we come here, we might want to control the speed as well. In this case we can actually change the signal, so the more pressure or electrical signal we give to our valves, the more the valve opens, which changes our speed. Essentially no ramp in this one, but you can, so you've got the two functions, the ramp and the speed is the important bit to take over this. Now there are lots of different ways of achieving this. We won't go through them all in this presentation, but now we've got a typical industrial proportional valve system. So we've got 4 limit switches, and the reason for this is we always want to stop in the same place. So when we change the load, that means this position we stop at, if we were decelerating from here, the slope of the curve would be different, so we'd be stopping in different places. So by slowing it down at the very end, we can consistently control the position that we stop at. You'll note the speed still changes because, as we found out earlier, the flow through a valve depends on its pressure drop across it, which depends on its low pressure. So we're stopping in the same position whatever the loads on this system are. We can also now change. You can have a little play on this. You can set your limit switches. So we can click on this one and we can change the value we give at this limit switch, change its position, and then when we run it now, it creeps back for a lot further and a lot slower. So you can experiment with the loads and see the differences in performance. Learn the way to learn, just to experiment, and then you understand exactly what's happening in your system.